Hi everybody, this is Gigi from Kauai Community College. In this video, I will be talking about regions between curves, okay? And this is the third example in this topic. Okay, so you should go ahead and watch my previous two before you watch this one. All right, so here is the scenario. Suppose the region is bounded by the parabola 2x squared plus 10, y equals 4x plus 16, that's a line, x equal to -2, and x equal to 5. So what I'm going to do is I'm going to go ahead and to save us some time here, I'm going to go ahead and go into Desmo and take the graph, then copy it over. It should look like this here, okay? And just take a look and let's study what region we are talking about. Okay, so we have region between these curves here, right? So the red is the parabola, that's the red right here, that's the red, okay? And then the blue is the line. And then the green is the x equals -2, and the purple, I don't have purple, so I think I'm gonna say orange there. The last one right there is the x equal to 5, right? So let's go ahead and take a look at these regions. I have region 1 right here in between the two curves, right? And the line. And I have region 2. Then I also have region number 3. So as we can see, we have to divide up the integral here into 3 different regions. Okay, so first, region 1. You would have, in this case, we would have the vertical, right? So we're looking at the vertical strip here, like this. Okay, so it would be red minus blue. And we are integrating with respect to x. So it would be the integral from -2 to -1. And I have went ahead and used decimal to find the intersection there. Okay, so -1, it's from -2 to -1, and it would be, the height of my rectangle would be 2x squared plus 10 minus 4x plus 16, and we are integrating that with respect to x. Okay, and I'm going to leave it to you to go ahead and simplify and clean that up. Now region number 2. Okay, so region number 2 is going to be from -1. This region right here is going to be from -1 to 3, right? -1 to 3. And the vertical strips here would be blue minus red. Okay, blue minus red, that would be the line minus the parabola. So I would have the integral from -1 to 3, and I would do line, which is 4x plus 16 minus the parabola, and that is 2x squared plus 10. And we are integrating with respect to dx right here, with respect to x, because that is the base of my rectangular strip. Okay, and then the third region, that region number 3, and that would be this region right here. And now we're back to red minus blue, but we are going from 3, which is here, to 5. Okay, so integral from 3 to 5 of parabola, which would be 2x squared plus 10 minus the blue, which would be 4x minus 16. And we are integrating that with respect to x, and dx being the base of my rectangular strip that go from here to here, right? All right, so that is that. We can go ahead and simplify and make the integral a little bit cleaner. Add them all up, you should get the total area of the regions between those curves. All right, so if we were to combine them, the total area would be, we would say the total area of this region, the area, is going to be the sum of all the integrals. So it would be the integral from -2 to 1. And if you clean that part up, you would have 2x squared minus 4x minus 6, integrating that with respect to x, okay, plus the integral from -1 to 3, and if we clean that up, we should get -2x squared plus 4x plus 6, integrating that with respect to x, plus the green one, the integral from 3 to 5 of 2x squared minus 4x minus 6 with respect to x. Okay, if you go ahead and calculate those integrals, add them together, that is the area between those curves.